So we're going to start session 2 by starting to examine some other important next steps for Flower. We're going to consider how Flower can work with the community through a series of initiatives. We're going to discuss some of the initiatives that have been successful in the past and some of the initiatives that we're going to push forward in the future. And to do that, we've got two fantastic research scientists from Flower Labs, Javier and Jan. I'm going to hand over to Javier first, and we can get the session underway. So over to Javier.
Thank you, Nick. So in the next 5 minutes, I'm going to tell you about some of the amazing community initiatives we have been running over the last few months. But first, I want to draw the attention to you, the Flower community. I think we have grown a lot in the last year alone. For example, the number of open source projects that are available currently in GitHub has risen by over 60%, and some of them are quite transformative, like, for example, the FL4 Health project that you will hear more about from the from the Vector Institute in Canada. The number of contributors has also increased by more than double, and some of you have been helping us to improve the core framework. Others have been working on examples, others improving the documentation and creating new tutorials. And another dimension where we see our community really thriving is in platforms like our Slack workspace, where we are more than 3,000 people using Flower or interested in federated learning in general. And we expect that we will see all these kind of super nice interactions and even more interesting ones in our recently launched Discuss forum. And because of this, it's not a surprise that now most of the latest and greatest research in federated learning is created using Flower. You heard about some of them in the previous talks. There are quite a few papers presented in NeurIPS, ICLR, ICML, and the top computer vision conferences. And this is a trend that we started noticing earlier last year, and that motivated us to launch our biggest initiative so far, which we called the Summer of Reproducibility. So for those of you that were not in the Flower Summit last year, we launched this initiative to address a crisis, the crisis of reproducibility in machine learning, which is particularly pronounced in federated learning. Because as you know, while reproducibility in machine learning is difficult because you have models, how you initialize the model, hyperparameters, optimizer, and so on. In federated learning, this gets exponentially worse because you introduce a new big range of hyperparameters, like how many clients do I have, how many clients per round, how do I sample the clients. So this makes the reproducibility of experiments, of research, super challenging. So we wanted to address this. What the Summer of Reproducibility ended up being was a six-month community-led effort with a super ambitious goal of constructing the largest collection of FL baselines that anyone could reproduce super easily. The process involved 4 simple stages. You could propose your own baseline, the paper you wanted to reproduce, or you could pick one from a list that we created. Then you will fork the repo, open a PR, and then start writing your baseline, trying to reproduce the experiments you chose from the paper. And for the most part, you will be interacting with me, and I helped some of you more. Some of you didn't need any help to complete the baseline successfully. After a bit of back and forth on GitHub, most of you managed to complete the baseline. I ran all the experiments you proposed, and eventually we merged your baseline. And you also got a really nice reward. We were really amazed by the super great adoption of this initiative that we saw last year when we announced it, and within just a few days, almost 50 of the baselines we proposed were chosen by some of you. Some of you are actually in the room, and I'm sure that many of you are online. So these are the names I put together earlier this morning of all the contributors that managed to finish the Summer of Reproducibility. I'm particularly super proud of all of you putting all the hard effort, so I think we should give a round of applause to all of them. Let me tell you a bit more about the Summer of Reproducibility, the outcome. So 26 contributors completed it. These are all the baselines highlighted in a more intense yellow that you can use right away in Flower. One of the nicest things about the Flower baselines is that they follow the same interface, they follow the same project structure. So, for example, in mine, you are very particularly interested on developing FL methods that work with heterogeneous clients, like clients that have different compute capabilities or they are under different communication bandwidths. So you might want to choose techniques like DepthFL or Fjord. These are super popular frameworks in FL. Well, if later on you say you want to do some complex, non-complex optimization using Dasha, you will see that all the time you spend understanding the code in Fjord is also very useful for Dasha because the code structure is identical. The config system is also identical, so making changes to suit your particular experimental setup is super easy. Not everything is about computer vision. We have also baselines that do speech, which is a super interesting dimension and modality for privacy-preserving machine learning. So with this, we are confident that this is the largest collection of FL baselines. If you check other places, like, for example, papers with code, you will find way fewer baselines implemented in a unified framework. And we are super happy with the result. So far, the Summer of Reproducibility has been our biggest community-wide project. And we remain really committed to open source. So that's why we are maintaining these baselines. More baselines are coming. And we are updating all the baselines to Flower Next in the next couple of months. But there is something bigger than the Summer of Reproducibility that we have been working on very hard in the last few months. And to tell you everything about it, here is my colleague, Jan.
Okay, thanks, Javier. Yeah, so as we all know, large language model, the LLM, has got remarkable performance on different tasks and domains. But adoption of LLM federated fine-tuning is lagging behind the other aspects of the LLM-related work. But the LLM federated fine-tuning can simplify the creation of more personalized and domain-specific LLMs that requires the synthesis of data. However, people usually struggle with like building up the LLMs in federated environments due to the fact that the LLM is typically resource-consuming and also a lack of a user-friendly tool to do that. So today marks a turning point. So we're glad to introduce our next Flower community initiative, the LLM Flower Tune, so which makes the federated LLM fine-tuning very easy to do. So what does LLM Flower Tune work? So it basically integrates a bundle of techniques. It includes the Flower dataset. It used to download, partition, and do the pre-processing on the training data. And easy pre-trained LLM adaptation, which is that you can easily choose whatever base model as a starting point for the LLM fine-tuning, for example, the Llama 2 or any other popular pre-trained model. And also we adopt the parameter-efficient fine-tuning, the LoRa technique, and also we use the quantization during training. Additionally, with the Flower simulation engine, we can efficiently make use of the compute resource to do the FL simulation. So all of them come together, which makes the federated LLM fine-tuning that can be done with just a single GPU. And we have released our first example of the LLM Flower fine-tune. And just feel free to try it now if you get your laptop with you. And I think you must have other many ideas to explore on this domain, and also probably want to adapt this to other domain. So here's the thing. We will launch a LLM Flower Tune leaderboard. So in this competition, we will release a series of tasks on different domains with a baseline performed model. So the task includes the general NLP task, the finance, medical, and also coding-related task. So if you believe your model can beat the baseline model, so we just invite you to immediately submit your code and the model to get into the leaderboard. So now let's see an example of the general NLP task. So we benchmarked 8 models here, and you can see it's on the Alpaca GPT-4 dataset, and you can see the training loss shows a healthy dropping lines on all settings. And as for the VRAM cost, you can see that the 22 gigabyte is enough to train the biggest model, and the smallest model only take around 11 gigabyte to finish that. So that means it's easy to do the federated fine-tuning, the LLM federated fine-tuning with just a single GPU. For example, if you have a 3090 with a 24 VRAM GPU, and also even you can concurrently train more than one client if you have a more powerful GPU. So is a federated trained LLM really useful? Let's just test it with a question. So the question is, what's the ideal day plan in London? And here's the answer generated from a model from the federated training. And you see that the Big Bang and House of the Parliament, London Eye, it seems a very, very nice plan, right? Okay, so how to participate in this leaderboard? It's quite simple. Let's just walk you through the workflow. So at the first step, you just need to choose a task, and then you just design your LLM training based on a given template. And each task will have its own specific evaluation metric. So just test your model with evaluation metric and make sure it has a high performance. And finally, just submit it and secure your spot on the leaderboard. All right. So we believe that your contribution will pave a way to a future where more personalized, domain-specific, and the data-sensitive LLMs will be within the reach of everyone. So that's all the content we will want to share with you about the Flower Community Initiative. So we finished the summer reproducibility, and we will release the LLM Flower Tune leaderboard soon. Thanks for your attention. We're happy to answer any questions.
Do we have questions for the room? From the room or online? Oh, down here? Let me just take it.
Hello, thank you. Hello, guys. Thank you very much. I think we have been in contact over the Slack community. I just want to ask about the baseline that you are working on. Are they going to be somehow implementable in TensorFlow? Because I have seen some of them more in PyTorch. And I work in both of them, but mainly right now my work is based on TensorFlow, so I have that question.
Good question. Currently, we have baselines on TensorFlow. The majority are in PyTorch, because that's what people seem to be preferring. But TensorFlow, PyTorch, XGBoost, we have all three. But you are really free to choose whatever framework you want that is more appropriate for your interest and fits better your hardware, for example.
More questions? How about online, Charles? Oh, while Charles looks, I'm going to hand it over to this guy right here.
So I'm curious about this LLM Flower Tune leaderboard, how to participate regarding how designed the task. So for the training, evaluation, and the number of the clients, server, it should somehow is already given, or it should be fixed, or because I'm not,
Thanks for the question. So currently we will release it soon, but we are planning to have a kind of fixed experiment setting for everyone, so that it could just to fair comparison between different methods. Yeah, so that's a current plan.
Okay, Charles, anything there?
We have one person asking if the example for LoRa with Flower is already available or not.
The answer is yes. So we already have released the first example, which used LoRa to train the model on, as I mentioned, the Alpaca GPT-4 dataset. So you can just try it online.
Perfect. Well, that's it for this talk. Thank you so much, Jan and Javier.